So today we're going to go over some kinematics practice problems. Starting out, a car travels at a constant speed of 20 meters a second for 10 seconds. What is the total distance traveled by the car? And what is the displacement of the car if it starts from the origin and changes direction at 7 seconds? So for part A, we just simply need to use the formula distance is equal to velocity multiplied by time. In our case, this means it'll be 20 meters a second times 10 seconds. And this will give us the answer of 200 meters traveled. Now for part B, we'll break this up into two sections. There'll be the distance traveled for the first 7 seconds, and we'll subtract the last 3 seconds since it switches directions. So we'll call it distance 1 for the first 7 seconds equals VT1. So we have 20 meters a second times 10 seconds. Or, sorry, times 7 seconds, my bad. And that equals 140 meters. Now, the second part, where it travels 3 seconds backwards, that distance will be called d2. And it travels for 3 seconds. Sorry, let's make that negative 20 meters a second since it switched directions. And that means it traveled negative 60 meters. So the total displacement will be d1 plus d2, which is equal to 140 minus 60, meaning that the total displacement was 80 meters. For our next example, a ball is thrown straight up with an initial velocity of 15 meters a second. How long does it take to reach the maximum height, and what is the maximum height of the ball? So for part A, let's start by writing down the variables that we know. The initial velocity is equal to 15 meters a second. The final velocity will be 0 because that will be when it changes direction at the maximum height. And the acceleration is just the acceleration due to gravity, which is equal to negative 9.81 meters a second squared. Now, to find the time it'll take to reach the maximum height, let's use the formula final velocity is equal to initial velocity plus the acceleration times time. If we rearrange this, we can solve for time. We'll get the final velocity minus initial velocity, all divided by acceleration. Now, plugging in our variables, we have 0 minus 15 divided by negative 9.81 is equal to time. Now, if we calculate this, look at time is equal to 1.53 seconds. Now let's do part B of this question. To do this, we'll use the formula height is equal to the initial velocity times time plus 1/2 acceleration times time squared. We just need to simply plug in all the values that we have. Let's look at this our final value, where the height is equal to 11.5 meters at the maximum height. So for our next example, a car accelerates from rest at a constant rate of 3 meters a second squared for 8 seconds. What is the final velocity of the car and how far does it travel? Let's start by writing down what we know. The acceleration is 3 meters a second squared. It travels for 8 seconds, or accelerates for 8 seconds. And it starts with an initial velocity of 0 because it starts at rest. So now to find the final velocity of the car, let's use the equation. The final velocity is equal to the initial velocity plus acceleration times time. If we plug in our variables, we get that the final velocity is then equal to 0 plus 3 times 8, which is equal to 24 meters a second. Now for part B, let's use the formula. Distance is equal to the initial velocity times time plus 1/2 acceleration times time squared. Plugging in our variables, we have 0 times 8 plus 1/2 times 3 times 8 squared. And then this gives us our answer if the distance it travels is equal to 96 meters. For this next example, an object is dropped from a height of 50 meters. How long does it take for the object to reach the ground? And what is the velocity of the object just before it hits the ground? Let's start by writing down what we know. It travels a distance of 50 meters. The initial velocity is 0. And the acceleration is just the acceleration due to gravity. So for part A, to find how long it'll take to reach the ground, let's use the formula. Distance is equal to the initial velocity times time plus 1/2 acceleration times time squared. Since we know the initial velocity is 0, we can drop this term, which will then leave us with just the distance is equal to 1/2 acceleration times time squared. Now let's rearrange this formula to solve for time. If we do so, we'll be left with time is equal to the 2 times the distance divided by the acceleration and the square root of the entire thing. If we plug in the values that we have, taking the positive value for acceleration so that we can do the square root, we're left with the time is equal to 2 times 50 all over 9.81. The square root of that. So time is equal to the square root of 100 over 9.81. And this is equal to 3.19 seconds. Now for part B. We can use the formula that the change in velocity is simply just the acceleration times time. Since the initial velocity is 0, this means the change in velocity will be the final velocity. Plug in the values that we have. This gives us a final velocity of about 31.26 meters a second.